lab exercise, or lab 3 exercise 1, what we're really going to go through is how to do a two-sample t-test. So we need to be really careful about which two-sample test we use. I want to draw your attention to this flow chart here that asks questions and then leads us in the appropriate direction of which way we need to go. So here the first idea is, I guess, to understand the question that we're being asked. So here, what they're trying to do is compare children who see television commercials if they can remember the advertisement. So here, 34 children are divided into two different groups. One group, which was 18 of those 34, were shown an ad with candy, complete with audio and video. And the other group, which had 16 children, were only shown an advertisement with just video. So I guess the question is, does the audio help a child remember some of the advertising? So some of the things that we need to pay attention to here is in total, I guess we have 34 children. In one of the group, we have 18, and in one of the group, we have 16. The data is available for download here, so I actually downloaded it, and let's just have a look at it. So I called it Lab 3 Problem 1. And so I just went through the typical way of downloading the data set by going import data set. Hopefully you know how to do that by now. So here, it's a little bit squishy. Let me just make it bigger and then redo it. Here, the group that got only video and the group that got audio as well as the video. So here's one of the children in one of the groups and then one of the children in the other groups. And notice that one group only has 16 and the other group has 18. So when it comes to trying to decide the proper way to deal with this, the first thing we need to do is ask if our samples are paired. So is there a reason to believe that child 1 from the video only group should be compared to child 1 in the audio and visual group? So should this 2 go with this 6? Should this 2 go with this 2? Or should this 2 go with any of these numbers? In this case, it's really easy to decide that these samples cannot be paired simply because they don't have the same sample size. Notice that here you've got 16 children in the one group and 18 children in the other group. So it makes it really easy to decide that they can't be paired because not everybody in this audio and visual group has ability to be paired because there aren't the same number of points. What we should also do then, I guess, is test to see what the normalities are. So it looks like before I did that, it looks like I also wanted to show you a little bit here about these NAs. So here, these NAs just mean that this column is shorter than this column, and instead of putting zeros, which would be a meaningful number, it's trying to just say there's no number here at all, which can cause a problem. So like when you try to run a command like maybe find the mean of this column, it wouldn't be surprising then, typically you would just say mean, and then I guess I called the data lab 3 problem 1, and then I put a dollar sign and say I'm looking for the mean of the first column, which was called the video only. An issue happens here because when it's trying to find the mean, these aren't numbers, so it can't really deal with it. So if you do have NAs in your data, then here use the command na.remove or na.rm equal to true, and then you can actually find out what the mean is when you ignore. Now that we've looked a little bit at the data and we want to compare these two groups, specifically we're trying to see if it's the same or not. So we're trying to find if the mean of video only is the same or not the same as audio and visual. We really need to consider what the most appropriate way to do this is. So are the samples paired? When we have a look at what the data looks like here, let me just see it again. Here, the data could not possibly be paired because there's a different amount of samples in the one column than in the other. The other reason that it doesn't make sense to pair here is because there's no natural pairing. As I said before, would this 2 go with this 6 or with this 2 or with this 3? There's no reason to think that these are the same people being given the video only and then the audio and the visual. So they're different people. There's no real way to link those two together. So here, are the samples paired? The answer should be no. Are the data normally distributed? So here, let's go ahead and make sure that we've installed nortest. Okay, so if I try to install nortest, then I'll go through and make sure that it's there. And I'll also load nortest. Then once I've got nortest package installed and loaded, then I can do the normality test for the video group. And you can see this p-value is slightly over 5%, therefore it's looking normal. And I can also do the p-value for the normality test of the audio and the visual, and you can also see that that is over 5% as well. So here I went through asking if the data was normal, and because I got relatively large p-values, at least larger than 5%, then I'm going to fail to reject, and I'm going to say they are normal. So at this point, then here I'm suggesting that these data are normal, or at least normal enough. And my next now step is to perform Levene's test. Levene's test is about if the spreads are equal. So whether you say the variances are equal, or if you're saying the standard deviations are equal, here I've used sigmas. Here I've got sigma squared. So either you can write it as the variances are equal, or if you can write it as the standard deviations are equal or not equal. We have to get our data into stacked columns. So again, let me just remind you what our data currently looks like. That is 2 separate columns. This command here, stack, so you can stack the data that you've got in a data frame. What that does is here, actually, I guess we had 3 columns. We had this column of just 1, 2, 3, 4 to 18. We've got this column of video only, and we've got this column of audio and visual. And so what that did was it just put this column, and then it copied this column, and then it copied this column, and it made a new column about the titles where these numbers came from. So first we had 1 through 18, and this was coming from the column called X. Then we had the other column that was coming from the column called video only, and then we had the other numbers coming from audio visual. So that's not quite what we're looking for, because we really didn't care about having this first column that was just the numbers 1 through 18. So here, if instead I use the command stack, but then I say on columns 2 through 3, you'll see I miss out on having these numbers 1 through 18, and I go right to stacking only the second and the third column here. So finally, I just have these values from those 2 columns specifically. I'm going to do that same command that I just did, but I'm going to now call it the letter A. So when I now press A, I can actually get these. Now, to perform Levene's test, which of course is the test of equal standard deviation or equal variance, if you like to write it that way, I need to make sure that in my packages, I have a package called car installed. So I'm going to make sure that car is installed. And after car is all properly installed, of course, I need to load it as well. And now that I've got the data in a stacked format, meaning that it looks like the numbers are all in one column and then where they came from is in another column, under the car package, there is a command called Levene test. And so here in Levene test, I am going to reference this stacked column that I called A, and I'm going to say A $, these were the values, and then comma A $, these where they came from. And then here I can just press enter, and I'm going to get an F test statistic, and I'm going to get a p-value, and here are the degrees of freedom. So here, this is the F distribution, which is definitely a different distribution than either Z distribution or T distribution, which are you are used to working on. But here, the F distribution is a right-skewed distribution. It's not bell-shaped like Z or T. But at the same time, here what I'm saying is the probability of the F distribution with 1 degree of freedom in the numerator and 32 degrees of freedom in the denominator. You can see that here, 1 degree of freedom and 32 degrees of freedom. And when I've got the test statistic that I was given, the probability of being greater then that is the p-value. So here's the p-value. You use the same rules with this p-value as you do with every other p-value. Because it is greater than alpha, because it's greater than 5%, then I will fail to reject the null hypothesis. Here's the null hypothesis. So basically what I'm saying is that these standard deviations look to be similar. I've run Levene's test, and I know that the standard deviations appear to be similar. So here I've just run Levene's test, and were the variance is the same, we just had a high p-value, so the answer should be yes. Now I know which two-sample t-test to use. So I'm finally getting to the point where I can actually do the hypothesis test on whether the means are the same or not. And so here, the test that I need now to run is a t-test. It's a two-sample t-test. And here I want to make sure that I'm going back to my original data. So I don't need stacked data. So here I had to use the stacked data to get Levene's result. But instead of referencing the data that I called A, I'm going to go back to the data that I called lab 3 problem 1. And then here I'm going to say video only as the first mu. And I'm going to say audio and visual as the second mu. You want to make sure that if you have written your hypothesis where you have the first mu be video and the second mean be audio and visual, that you want to make sure that you continue that same order when you're using R. I want my video to be the thing that I went first, and the audio and visual to be the thing that I did second. And then here, what's the sign? In this particular case, I am doing a two-sided test because the sign in the alternative hypothesis was not equal to. The number that is associated with the hypothesis, there is no number, so that's going to be a 0. Oops. Are they paired? We already went through this. When we went through this chart, we said it was not paired, so I'm going to say paired is equal to false. Are the variances equal? That is the result I just got from Levene's test. In this case, Levene's test had a larger than alpha p-value, so it looks like the variances are equal. If this had a small p-value, then you would say the variances are not equal. Okay, so in this particular case, I'm going to say the variances were equal. And finally, I can give the confidence level, if I like, to be 95%. Okay, so here, this is the two-sampled test with equal variance. I get a test statistic here, I get a degree of freedom, and ultimately I get a p-value. My p-value is very large. Okay, so here I just wrote down, here's the test statistic. Because it's a two-tailed test, half of the p-value is on this side. And so if I multiply that half area by 2, I will get the full p-value, which is a very large p-value. So I would fail to reject the null hypothesis. It looks like the mean for video only is not significantly different or is quite close to being the same to the audio and video club. So it really doesn't seem like there's a significant difference that the sound is giving. It seems like the video and both the audio and the visual are not significantly different from each other. The other thing that I wanted to draw your attention to is, especially when I've got the sign being the two-sided sign or the not equal to sign, um, uh, your R will also give you a confidence interval. So here, what this is saying is that the difference between the two averages should be between this value and this value. So if I took um, mu of one, subtract mu of the other, then on the one hand, um, perhaps the second value is bigger, which leads to a negative, or on the other hand, perhaps the first number is bigger than the second, which is leading to a positive number. So here you can see that the number 0 happens to be inside the confidence interval. So another way of evaluating this is, one way is with the p-value, saying I failed to reject because my p-value is so large. The other way is saying I've identified the number in the null hypothesis as actually being inside of the confidence interval, which means that it is possible and, and possibly plausible that one of the possible answers for the difference is in fact 0. It is inside of the range that we are saying is possible. If you had gotten a Levene's result, okay, so if you had gotten the Levene's result to have a small p-value, then the only thing that you would change would be saying it looks like the variance is not equal. Okay, so you'd say false there. And here you would get a different degree of freedom, a different test statistic, and a different p-value. It might be close, but they might be slightly different as well. So make sure that you are running Levene's test properly so that you can know exactly which two-sample t-test you should be running, either one with equal variance or one without equal variance. Comes to actually putting all of this into your web work, we can and need to make sure that we pay attention to all the things that we've done and know which p-values go with which hypothesis. So when you're talking about if the means are actually different, that actually resulted from the two-sample t-test. That was the test on the means. We also had a p-value that was talking about if the spreads were the same, and we also had two separate p-values talking about if the data was normal or not. So when you're going through actually putting your answers in, the hypothesis for the means is clearly stated with mu's. And then if you were going to look at box plots, one thing that you're trying to look at is to see if, in fact, your box plots seem to have a similar width. In this case, it's not surprising that when we did Levene's test, we found that the widths were similar, because from this picture, it certainly looks like these box plots are sort of similar widths. So even from this box plots or from running the Levene's test, you can say, yeah, it really looks like these standard deviations are similar. Okay, when the question continues on and it's talking about when you were testing the difference of means, which test statistic, which p-value, which degree of freedom should you be giving it? This is talking about the test on means. So that was the two-sample t-test on means, not the test on sigmas and not the test on normality. So here we should use the results that we got from the two-sample t-test. How we interpret the p-values continues to be similar to how we've always done it in this course. And then here it's also asking for that confidence interval, which I also found. Lastly, it's trying to let you realize what were the steps that got you to this point. And this is the part that's really related to this flowchart. The samples weren't paired. The data did appear normal. Levene's test said the standard deviations were the same. And finally, we did that two-sample variance test. So here we said, what are the conditions that led you here? The variances were the same. The video group was normal. The samples should be independent of each other. That means they're not paired. And here, the other group, the audio and visual group, was also normal.